Welcome to EGBT channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends also. In this video, I will discuss about the source transformation technique. This technique which can be very useful to reduce the given network problem. That means you can change one source to another source. That technique is called the source transformation. You can transform the value of given one source into the value of given other source. We know we have two types of sources in the network. That is one is we have voltage source 1. Similarly, we have current source 1. It can represent plus minus voltage source, and the current source represent with the arrow mark and represent the value of phi and represents the value of V here. Okay, that means if the voltage source can be converted into current source as well as the current source can be converted into voltage source, then that technique is called as source transformation technique. Here we will transform the voltage source into current source and we transform the current source into voltage source. Then here one point, remember here the important point is here, always the resistance is connected in series with the voltage source and the resistance is connected in parallel with current source to transform one source to the another source. For example, if in the given problem a voltage source is given in series with resistance, then that voltage source we can transform into current source. Then that same resistance R will be connected across the current source value. Here we can find out the value of current source. We know the value of voltage, then according to Ohm's law, V equal to IR, then we have to find out the value of current source from I equal to V by R. Then the given voltage source can be transformed into current source. In the same way, in the given problem, for example, a current source is given. A current source always having in parallel with resistance. In the given problem, the current source is like that. Then that current source can be transformed into voltage source. Then that voltage source always in series with the same resistance R. Then you have to find out the value of voltage here from Ohm's law, V equal to I into R. We know R value and I values are given in the problem. Then we can transform into voltage source V equal to IR. Okay, by using these two formulas, voltage to current, current to voltage, then so by applying source transformation technique, you have to find out the required response in the given network problem. For example, I am taking one circuit here. Find the value of current I1 in the given circuit by applying source transformation technique. Here, the value here, our aim is to find out this branch current, loop current I1. That's why we cannot disturb the given loop. Why? Because here our required is to find out the loop current I1. Then in the given problem, 3 amperes and 5 ohms form a parallel current source, and also 5 amperes and 9 ohms form a current source problem. Then this current source you can change into voltage source. Then the complete circuit becomes a single loop circuit. Then how to change that value? For example, consider the source is V1. To change 3 amperes current source, then V equal to IR. I value is 3 and R value is 5. Then the voltage source value is 15. And what about second source? Then second current value is 5. That is 5 amperes is given and 9 ohms are given. V equal to IR. Then second voltage source value is 45 volts. That is the 3 amperes current source change into voltage source by 15 volts. The 5 amperes current source change into voltage source by 45 volts. Then the given circuit can be changed. For every step, you must also draw the equivalent circuit at every step after taking simplification process. Then here the current source can be changed into voltage source, then in series with the resistance. Again, the second current source change into voltage source in series with the resistance. Then again the given circuit, we have another voltage source here, and this is the given circuit. This is 7 ohms given and plus minus given, that is 10 volts this value, and this is 5 ohms, this is 9 ohms. Then observe here, and also given the current another source value, that is 4 volts in the given problem. Okay, here observe the direction of the current source. 3 ampere source direction is in anti-clockwise direction. That's why always the current will be taken from minus to plus. That's why this is the minus and this is the plus. For another source 5 amperes also in downwards, then the current direction is from minus to plus. Then minus to plus the voltage source. This voltage source will be 45 volts and this voltage source will be 15 volts. Then what is our required here in this problem? To find out the response current here. Current direction is given like that. That is anti-clockwise direction. Then the current is taken as I1 here. To find out the value of I1. Already in the problem, the direction of current is given. That is clockwise. Then here, how to find out I1? Simply, that means apply KVL to the circuit. Apply KVL to the loop. A single loop is formed. Then the given circuit can be reduced to single loop. Then it is easy to find out the loop current. Simply apply KVL here. The current direction from the source, that is the 10 voltage source, from minus to plus. That's why lower potential to higher potential. 10 take positive 10. Similarly, we know always for the elements, the current passing from minus to plus. That's why the source here, what is the drop across 7? That is minus 7 into I1. For voltage source 15, the current is from plus to minus, then lower potential. That's why you can take here minus 15. The current direction for 15 volt is plus to minus, that is higher to lower potential. That's why we are taking as minus 15. Similarly, for 5 ohms, minus to 15, that's why the drop is minus 5 I1. That is the voltage drop across 5. V equal to IR. That's why 5 into I1. Similarly, for 45, minus 2 plus current is flowing. That is positive. Then positive 45. Then again for element plus to minus. That's why minus 9 into I1. And also for the source voltage source 4 volts. That's why plus to minus. That's why minus 4 equal to 0. This is the KVL equation. Then you can equating on both sides. What are the values here? 10 minus 15 minus plus 45 minus 4 equal to the unknown value taken as outside the equal 7I1 plus 5I1 plus 9I1. Then the values are here. Equivalent values 36 equal to 21 I1. Therefore, the required response I1 is 36 by 21. Then the value is 1.714 amperes. Okay, like that you can apply source transformation technique in the given network. Then you can reduce the circuit into a single loop equation. Then apply KVL or KCL according to problem. Then you can find out the required response. Please subscribe our channel and share to your friends.